These videos are for, need to look, January 13th or January 17th. If you're in 3B or 4B, this would be January 19th. We're looking at the trigonometric half angle formulas. We're going to see the formula and then talk about how they're useful. With the sine half angle formula is plus or minus 1 minus cosine of alpha over 2, and the cosine formula is similar, but it's 1 plus cosine of alpha over 2. So pretty basic formulas. There's not much going on here. And these formulas, they're kind of useful if we want to find a radian measure for something pi over 8, like pi over 8, 3 pi over 8, things like that. Then we could do use pi over 4 for that. However, if we want to find pi over 12, they're not very useful. We'd use the sum and difference formulas. So we're actually not going to use these to get new values. But what we can do with them is solve equations. So I'm actually going to solve two, maybe just one here on this first video, and then maybe another one on the second video and give you solutions. But here we want to solve this equation here. Also, I should preface that as we were solving these on warm-ups, we've been going through quadratics, how to solve quadratics. So that's come into play a few times as well in terms of solving these equations. And it might show up here. But here we want to find all solutions for each equation below within the interval 0 to 2 pi. And so let's try to solve it. Here we're trying to solve this equation. What I would recommend is try to get 0 on one side. Now another thing I would recommend, well, let's just do that. So if I want to try to get 0 over here, say, subtract this, subtract it over here. Now in class what we talked about is on this side of our equation, these are not alike because of the x over 2 here and the x. So we could not combine these. So what this side would become is 1 plus cosine squared minus 2 times alright. Oh, excuse me. Now, we're kind of at a roadblock. We don't know what we can do from here to help solve. There's no identities that deal with, maybe 1 plus cosine squared using the Pythagorean. However, I don't think we can get positive 1 and positive cosine squared on the same side. But what we can notice here is this x over 2. And because of this x over 2, this is a half angle, we could replace that with this side of the equation and just get x. Now one thing as an aside, I think I've mentioned this in the past. If it says cosine squared of x, another way we could write that is cosine of x, the entire quantity squared. And that's what we're going to do here. So I'll leave this as 1 plus cosine squared x minus 2. And instead of cosine of x over 2, I'm going to replace that, similar to here, I'm going to replace that with all of this. So plus or minus square root all of this squared, because we do still have that square. Now in class what we talked about is actually simplifying this. The 1 plus cosine squared, that's going to stay. Minus 2. Now let's talk about what would be left in the parentheses. Excuse me. Let's think about the positive and negative first. If we have a positive value squared, a positive value squared would still be positive. A negative value squared, or a negative times a negative, would also be positive. So essentially this plus or minus is going to go away. We don't need to worry about that anymore because of this square. And the square root. A square root squared, those are inverses. So actually the positive and negative is going to go away, and the square root is going to go away. So that what we have left is 1 plus cosine x over 2 The square goes away due to what we just talked about. And so we would be left with this. Now what we can do here is the 2's. These 2's would divide out. So this 2 would divide out this 2. So we would have 1 plus cosine squared x minus, we still need the parentheses because of this minus in front of it, equals 0. Now the parentheses are important here because we would need to distribute the minus sign. So this would become 1 plus cosine squared x minus 1 minus cosine x. Now we can get in something more manageable. The key piece here is noticing that if we have x over 2, we can use the half angle formula. That's the key piece here. And then simplifying. But now that we have that, we simplified, we've done things that we know to do. Now we have 1 minus 1. These two are like terms, but one's positive and one is negative. So this goes away. Now it would be great if these would combine, but they can't. You have something squared and something on its own, just cosine. So they won't combine. However, what we can do is they each have a cosine. Really, this is cosine times cosine. Here, this is just cosine. So what we can do if both terms have a quantity in common is we can factor that quantity out. So I'm going to factor a cosine out. If this were the same thing as cosine times cosine, you factor a cosine out. This term would be cosine x. I factored this out, so I'm just left with 1. And again, if you need to double check, you're reversing the distributive property. So if we do this, cosine times cosine would give us cosine squared. Cosine times -1 would give us negative cosine. So these two things, they are equivalent. From here we have something times something, those equal 0. So now we separate and solve like we have done in the past when we have two things multiply together, that equals 0. We know at least one of those is 0. From here we look, where does x equal 0? Well, cosine of x equals 0. Well, cosine of x equals 0 at pi over 2 and 3 pi over 2 on our unit circle. Here we would add 1, cosine of x equals 1. And in class we had a semi-interesting discussion about this. We said, where does cosine x equal 1? Well, cosine x equals 1 at 0 or 2 pi. So I'm actually going to write x equals 0 or x equals 2 pi. However, only one of these is correct based off of our interval up here. And hopefully we can recall that if it's a hard bracket like this, that means it touches at 0. If it's a soft bracket like this, that means it gets really, 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 really close to 2 pi, but never touches. And so 2 pi, since it does not touch at 2 pi, is not a correct solution. 0 would be. So for this equation, our solutions would be pi over 2, 3 pi over 2, and 0. If you need to pause, rewind, please, by all means, do that. If you have questions anywhere about this, please ask me. I'm going to end the video here, solve one more equation, and then I'll give you solutions to the last equation.